Hello everyone. In this video, we are going to solve question number 1 of GATE 2012 physics paper. This paper is related to mathematical physics. The question is, identify the correct statement for the following vectors. A is equal to 3 iota plus 2j cap and B is equal to iota plus 2j cap. There are 4 options. So we have to find out what is the correct option for this question. So we have been given two vectors. A is 3 iota times plus 2j cap and B is equal to I plus 2j cap. So in vector notation we can just write it as 3, 2, 1, comma 2. So we can write in vector notation or matrix formed by these two vectors in this form. Now one of the property is that if two vectors are if the determinant, let us assume that this matrix formed by these two vectors is A. So if determinant of this matrix is equal to 0, then we say that these two vectors are linearly dependent. It is because determinant of a matrix actually represents, can be, for example, if a matrix determinant A, then it actually represents the volume occupied by this volume occupied. For example, if we have a three-dimensional matrix, then the determinant of this matrix, of this three-dimensional matrix, will give us the volume occupied by the three-dimensional matrix, which if equal to 0, that means all the vectors are lying in the same plane and hence they are linearly dependent. And if determinant is not equal to 0, that means there is some finite volume occupied with these three vectors, and hence all the three vectors must not be lying on the same plane, and hence they are linearly independent because they are not lying on the same plane. Similarly, this is for 3D case because we are talking about volume. But similarly, we can also apply this property to the 2D case also. So if determinant of this matrix come out to be 0, we will say that it is dependent. So with the matrix is three, 2, 1, 2. So its determinant will be simple. 3 times 2 minus 1 times 2, which is 4. So this is not equal to 0. And as discussed, if determinant is not equal to 0, that means they are linearly independent. So option A is correct. For option B, it is saying that vectors A and B are linear. So option B is not wrong. Wrong. Option C says that vector A and B are orthogonal. So we know that for orthogonal vectors, dot products vanish. That is A times B should vanish. So just take the dot product between these two vectors will give us 3 plus 4. 3 times 1 plus 4. 3 plus 4, which is equal to 7, which is not equal to 0. So they are not orthogonal. Not orthogonal. And the last option says that the vectors A and B are normalized. Vector A is 3i plus 2j. So obviously it's not normalized because if we just take the magnitude, it's not coming out to be equal to 1. So normalize, if we just take it magnitude, it will be just something like under root 13. So 1 by root 13, 3i plus 2j. This is normalized, not the original vector which is given in the question. This is normalized, and this is a normalizing factor. Similarly, B is also I plus 2j. So the magnitude, it will be just root 5, and hence 1 by root 5 I plus 2. This is the normalized B vector. with the normalizing factor 1 by root 5. So option D is also wrong. So option D, option C and option B are wrong. So option A is correct. So A is the correct option for this question. Thank you for watching this video.